We are actually going to start this particular series for you people, and the series is basically aimed at cracking the RE-NEET exam, which is the date has already been announced by NTA. It will be on 21st of June. So in regards to that, we will try to complete all the topics for you in shortest possible manner. What I will be going to teach is, I will be going to teach today two chapters, that will be motion in a straight line and motion in a plane. So I'll try to cover in brief, I'll try to cover all the important concepts which are required to solve the questions, and we'll also take some questions based on the time frame. We will also take some questions so that your majority of the time is spent in analyzing the problems, and from this video you should expect that all your concepts are covered. So let's begin the particular topic. Let's start with motion in a straight line. Okay, the first topic which I'm trying to start is motion in a straight line. Motion in a straight line. So I'll be briefly discussing all the important concepts which are required to solve the problems. Let's quickly start it. The first thing is, we want to know what is distance and what is displacement. First topic is distance and displacement. When we are talking about distance and displacement, please understand, distance is basically the total path length followed by a particle. If you want to go from one point to another point, then whatever is the total path length followed by a particle, that will be called as distance. And displacement will be what? Displacement will be basically the change in the position vector of the particle. So whatever is the final position, whatever is the initial position, you subtract them, you will get the displacement of the particle. So what I can write, distance is nothing but, distance is total path length covered by a particle, and displacement is what? Displacement is the change in position vector, of particle. But always remember one thing, that distance will always be greater than or equal to magnitude of displacement. Always remember this thing, distance will always be greater than or equal to magnitude of displacement, because displacement is nothing but change in position. So it will always be the shortest length from initial point to final point. But distance can take any value, it can be more than displacement, it can be equal to displacement also. When the distance and displacement will be equal, when the particle is traveling in a straight line without changing its path, okay, without taking a turn. So basically this important inequality you should know. One more thing, if I want to calculate displacement vector, what I will do, displacement vector will be final position vector minus initial position vector. So this is basically the displacement. How to calculate this in vector form? Suppose this is the x-axis and this is the y-axis, and this is one point A. Suppose the initial position vector is r initial vector, and this is another point B. Suppose the final position vector is r final vector, then the displacement will be what? The displacement will be a vector which will be joining the initial point to the final point. So the initial to final point will be the displacement vector. You can apply the vector rules of addition to calculate the displacement. That will come out to be the r final vector minus r initial vector. And since it is the shortest path taken, that is why displacement has to be the minimum. The distance can be either equal to the displacement if you are actually going in a straight line from A to B, or the distance can be more also, because you can go like this also, you can go like this also, it can be anything. So distance can be more than displacement also. Let's come to the next concept. The next concept is speed and velocity. The next concept is speed and velocity. Beta, we have to cover the concepts, we have to cover a lot of concepts in a limited amount of time. That is why we'll cover the concepts with somewhat speed so that I can discuss some questions also. Speed and velocity. So in speed, basically if I want to calculate speed, then there is two types of speed. One is average speed and one is instantaneous speed. Average speed will be what? Average speed will be distance divided by time. Total distance covered by the particle divided by total time taken. What will be the value of instantaneous speed? Instantaneous speed is basically, it is written as v, and that will be equals to dx by dt. So basically average speed will be applied when you want to calculate the total distance traveled in a given time interval divided by the total time taken to cover that distance. That will be average speed. And when I'm talking about instantaneous speed, then instantaneous speed will be the speed at a particular instant of time. Whenever you want to find instantaneous speed, then it will be written v is equal to dx by dt. You have to differentiate the distance with respect to time to get the speed. And whenever you want to get average speed, it will be written as total distance by total time. Acha, one more thing. From here only one thing should be clear, that dx can be written as what? Dx can be written as v into dt. And v is equal to dx by dt. So dx can be written as v dt. If you integrate from 0 to t or from 0 to x, then the total distance which you will get, will be integration of v dt from 0 to t in this particular time interval. So this will be the distance covered by the particle. So remember one thing, whenever distance is given as a function of time and you want to find the speed, differentiate the term v is equal to dx by dt. Whenever speed is given as a function of time and you want to find the total distance, then integrate the speed with respect to time. If speed is constant, if v is equal to constant, that is particle is moving with uniform speed, then you can directly calculate distance. The distance will be directly equals to what? Speed multiplied by time. Then you can directly calculate speed into time, that will be the distance. So this is basically the concept of average speed and instantaneous speed. After that, the concept which we relate is the concept of velocity. Now when we talk about velocity, then here also there are two terms. One is average velocity and one is instantaneous velocity. So average velocity is given by what? Average velocity is given by v vector average. Like this we can write, or we can directly write v vector average. Okay? What will be the formula of average velocity? The formula of average velocity will be total displacement divided by total time. So total displacement is what? Total displacement is final position vector minus initial position vector divided by the total time taken. This is average velocity. If I want to calculate the instantaneous velocity, then the instantaneous velocity will be equals to v vector will be equals to dr vector by dt, or I can also write it as ds vector divided by dt. So this will give me the instantaneous velocity. Instantaneous velocity is the rate of change of displacement. Instantaneous speed is the rate of change of distance. If I want to get the total displacement from here, in the same way I can write integration v vector dt from 0 to t will give me the total displacement of the particle. So I hope these terms are clear: average velocity, instantaneous velocity, average speed and instantaneous speed. One more thing, if a particle is moving with a uniform velocity, please understand, if a particle is moving with a uniform velocity, then the magnitude of the velocity also has to remain same, the direction of the velocity also has to remain same. This can happen that the particle is moving with uniform velocity or the particle is moving with uniform speed. The speed is constant but the direction can change. Like in circular motion, the particle is moving with a uniform speed but the direction of the velocity is changing. So there we will not say that the particle is moving with a uniform velocity. There we will say that the particle is accelerating or the particle has acceleration. One more thing which can be asked from this particular case is that if I ask you, will the average velocity magnitude be always equal to the average speed? No. The magnitude of average velocity will be lesser than or equal to average speed, because average speed is depending on distance and average velocity magnitude is depending on displacement. So I can also write this thing that the magnitude of average velocity is always lesser than or equal to average speed. Plus please understand one thing, the magnitude of instantaneous velocity is always equal to the instantaneous speed. Average velocity magnitude is always lesser than or equal to average speed, but we can write that the magnitude of instantaneous velocity is always equal to the instantaneous speed. So v vector mod is equal to v, but v average vector mod is not equal to average speed. It is always lesser than or equal to average speed. So these are the few conceptual points which you must remember. Now based on this, very simple questions are being asked. Like let us suppose if I tell to you that the position of the particle is given by x is equal to t square plus 2t plus 4. Suppose I give you this particular x, and if I ask you find the average speed or average velocity in 2 seconds, and in the second case I ask you find the speed or the velocity at t is equal to 2 seconds. So in the first case, what I'm asking? In the first case, I'm asking find the average speed in 2 seconds. And in the second case, I'm asking find the instantaneous speed or instantaneous velocity at t equals to 2 seconds. So these two things I have to find. What I will do? I already told you that to calculate the average velocity, what you have to calculate? You have to calculate the change in position divided by total time. So for the first case, what you will do is at t equals to 0, you will find the value of x. What will be the value of x? This will be x initial. Put t equals to 0 here, x initial will be equals to 4. At t equals to 2 second, what you will get? X final will be how much? At t equals to 2 second, x final will be how much? It will be 4 plus 2 multiplied by 2, that is 4 plus 4. So how much you will get? You will get 12 meter. So x initial is 4 meter and x final is 12 meter. Now what will be the displacement of the particle? It will be x final minus x initial. So you will get it as 12 minus 4, that will be 8 meter. What will be the average velocity? Average velocity will be equals to total displacement, that is 8 divided by total time, that is 2. So the answer will be 4 meter per second. This will be the average velocity. And in the second question, they are asking find the instantaneous velocity at t equals to 2 seconds. For instantaneous, what I told, please differentiate this x with respect to time. So what you will get, if you differentiate, you will get 2t plus 2, and if you will put t is equal to 2 seconds, so you will get 2 into 2 plus 2, that is how much? 2 into 2 is 4, 4 plus 2 is 6 meter per second. So this is how you can calculate the instantaneous velocity and the average velocity by using this formula. So let's move to the next concept. Let's move to the next logic. We have discussed speed, velocity, we have discussed distance and displacement. Now let us come to the next concept, that is basically acceleration. Okay, let's come to the next concept, that is acceleration. So what is acceleration? Acceleration is basically, again, we will categorize it into two parts. Actual formula of acceleration is what? Actual formula of acceleration is that it is rate of change of velocity. But here also we will discuss average acceleration and instantaneous acceleration. So first let me discuss average acceleration. Now when I discuss average acceleration, then A average will be given by what, beta? A average will be equals to the final velocity minus the initial velocity divided by the total time taken. Or I can also write delta t. So this can be written as delta v vector divided by delta t. Obviously all these quantities, wherever I am writing a vector, all these quantities are vector quantities. One more thing, in the previous case when I was discussing average velocity and instantaneous velocity, what will be the direction of average velocity? It will be in the direction of displacement. When I am talking about instantaneous acceleration or average acceleration, then the average acceleration direction will be what? It will be in the direction of change in velocity. So I can say the direction is along delta v vector. Direction of average acceleration will be always along delta v vector. One more thing, this is average acceleration funda, delta v vector divided by delta v. Now if I want to discuss instantaneous acceleration, so what will be my instantaneous acceleration? Beta, instantaneous acceleration will be equals to A vector is equal to dv vector by dt. Or if I want to write it in magnitude form, then A can be written as dv by dt. So to calculate average acceleration, I will calculate total change in velocity divided by total time taken. To find the instantaneous acceleration, I will write dv by dt. One more thing, in instantaneous acceleration when I am writing, so if v as a function of time is given to me, I will write A is equal to dv by dt. Yes or no? But if I want to calculate the change in velocity, what I will do? If I want to calculate the change in velocity, then I will write dv is equal to A dt. Let's integrate it. When we will integrate it from 0 to t, from initial velocity v initial to v final, what we will get, beta? We will get delta v, which is v final minus v initial, is equal to integration A dt from 0 to t. So to get the value of delta v, we can directly integrate acceleration with respect to time from 0 to t to get the change in velocity. And if we want to find instantaneous acceleration, then we'll go for dv by dt. There is one more result for acceleration which you need to remember. A can also be written as, see, we know that it is dv by dt. Let us multiply it with dx and divide it by dx. So what we will write? We will write dx by dt multiplied by dv by dx. Dx by dt is nothing but velocity. So we can write acceleration by one more format, that is A is equal to v dv by dx. So all these results are important and the questions can almost be framed from all these results. So A is equal to v dv by dx, or a is equal to dv by dt. Total change in velocity can be written as integration a dt from 0 to t. Average acceleration is what? Instantaneous acceleration is what we have already discussed. One more thing, please understand that whenever we are talking about average acceleration, then the direction of that average acceleration will be always in the direction of change in velocity. I hope this particular thing is clear to you. Now, one more important point I want to discuss in this particular question. Understand one thing. Always remember that if your acceleration is uniform, what is the meaning of uniform acceleration? Uniform acceleration means magnitude and the direction of acceleration always has to be constant. Magnitude also cannot change of acceleration and direction of acceleration also cannot change. So if there is a particle which is moving with a uniform acceleration and if initial velocity, suppose I am taking initial velocity is u and acceleration, initial velocity and acceleration are collinear. If initial velocity and acceleration are collinear, then always remember the particle will follow a straight line path. If initial velocity and acceleration are collinear, particle covers a straight line path. Particle covers a straight line path. If initial velocity is 0 or if particle starts from rest, then also the particle will follow straight line path. Particle covers straight line path. Very important concept. So all these things I am writing in context with uniform acceleration. Whenever there is a particle moving under uniform acceleration and if the initial velocity of the particle is 0, then it will cover a straight line path. If the initial velocity or acceleration are collinear with each other, collinear means either initial velocity and acceleration both are in the same direction or both are in the opposite direction. In both these cases, the particle will basically follow a straight line path. But if initial velocity and acceleration are non-collinear, if initial velocity is not collinear with final velocity or with acceleration, then path will be parabola. Then the path of the particle will be parabola. Like in projectile motion, basically the initial velocity of the particle and the uniform acceleration are not in the same direction. So if they are not in the same direction, the path of the particle will be what? The path of the particle will be a parabolic path. That is called a projectile motion. So this thing should be clear to you. So these are the important points regarding acceleration which I wanted to discuss. Now, for uniform acceleration, please understand, whenever we are talking about uniform acceleration, so for uniform acceleration, always remember we can apply kinematic equations. For uniform acceleration, we can apply kinematic equations. How to apply these kinematic equations? What are the kinematic equations? First of all, let me write. The first equation is V is equal to U plus AT. Second equation is S is equal to UT plus half AT square. Third equation is V square is equal to U square plus 2AS. Fourth equation you can write displacement is equal to, all these are vector quantities, remember. This is the final velocity, this is initial velocity, this is acceleration, this is displacement, okay. So displacement can also be written as U plus V by 2 multiplied by T. That means in the case of uniformly accelerated motion, I can write the average velocity of the particle. The average velocity can be written as initial velocity plus final velocity by 2. Remember one thing, all these equations, whatever I am writing, they are basically written for only uniformly accelerated motion. If a particle is moving with uniform acceleration, you can directly apply this particular relation. And one more important relation is there, that the displacement in nth second can be written as U plus half A into 2n minus 1. This is the displacement of the particle in nth second. I hope you know all these things because you would have already done all these things. I'm just giving you a quick overview of all the related concepts which are applied in motion in a straight line. So these are the equations of kinematics which you can apply for uniformly accelerated motion. One very important concept regarding uniformly accelerated motion is the concept of motion under gravity. So let's quickly discuss motion under gravity also. Motion under gravity. So what is basically motion under gravity? Very simple to understand. Let us suppose I have a particle and this particle has been thrown up with a velocity u. This particle will go up, it will come down. Suppose it is under the effect of a uniform acceleration, that is g. Achha, by default I can take any direction, yes or no? I can take the acceleration direction as anything, I can take anything as the positive direction. Suppose I am taking upward direction as positive and downward direction as negative. So my acceleration will always be negative. My acceleration will always be negative. This is the initial velocity. I have thrown it up with a velocity u from the origin. Now I want to know what is the maximum height covered by the particle, how much time it will take to reach up, and what will be basically the total time of flight. So all these things I want to know. Again, you have to just apply kinematic equations because acceleration is negative, but it is uniform or it is constant. Because the acceleration is constant, all those kinematic equations which I discussed in the previous page, all these kinematic equations I can apply. Suppose if I want to calculate the maximum height, what I will do for calculating the maximum height? Maximum height can be written as h will be equals to what? Again I will apply what? Ut plus half it square I can apply, or I can also apply v square is equal to u square plus 2as. Whatever equation I will apply, I will get the answer because I don't know the time till now. I don't know from here to here how much is the time taken to reach the particle. So what I can do is I can apply v square is equal to u square plus 2 into a into s. What is the final velocity of the particle? Beta, the final velocity of the particle is 0. So 0 will be equals to u square plus 2 into. See, the acceleration of the particle is downward. So it will be minus g multiplied by displacement is upward. So it will be plus h. So I will get u square is equal to 2gh, or I can write h is equal to u square divided by 2g. So very important formula, please remember, the maximum height covered by a particle is basically given by u square by 2g. If I want to calculate the time to go from here to here, so how will I calculate the time? I can directly write v is equal to u plus at. From where to where? Let me mark also these points. This is A, this is B, and this is C. So from A to B I am writing the equation. What I will write? Final velocity is 0, initial velocity minus g into t. So the time to go from A to B, which is called as time of ascent, will be given by u by g. Time of ascent will be given by u by g. In the same way, when the particle will go down from B to C, from B to C also you will calculate the time, it will come out to be u by g. So what will be the total time of flight? It will be 2u divided by g. So one thing you have to remember is that the total time taken from here to here and back here will be 2u by g. The maximum height covered will be equals to what? U square by 2g. Now many questions can be asked from here. So basically the concepts which you have to apply in motion under gravity are this only, that you have to apply kinematic equations, but please be aware about the sign, that the sign should be proper. The positive direction has to be taken as upward, the downward direction is taken as downward negative. So you can apply anything. Okay? So I hope this particular thing is clear to you. Now let's come to the next concept. Sometimes in the case of motion under gravity, they also take this case in which they drop a particle from a particular height. Suppose they take this particular case in which the initial velocity of the particle is 0. So let us suppose the height from where they are dropping this particular object is h. Now here in this question they will ask you that just before striking the ground, what will be the velocity of the particle and what will be the time of flight. So two things they are asking: time of flight. Time of flight means the time in which the particle was in air, and they are asking you the value of v. So how to calculate? Again, I will do one thing. In this case, h is given to me, and since I am dropping the particle from this point, so this is treated as origin. From where my particle is starting its motion, I will treat that point as my origin. Downward direction I am taking it as negative, so g will obviously be negative. And let us suppose this point is A and this point is B. When I am coming from A to B, what will be my initial velocity? Sir, initial velocity is 0. Yes or no? Initial velocity is what? 0. What will be the displacement of the particle from here to here? Displacement is, sir, minus h. Displacement of the particle is how much? Minus h. What will be the acceleration of the particle? Sir, acceleration is minus g, because acceleration is also negative. Particle is displacing downwards, so displacement is also negative. And I want to find the time of flight and v. So first let me find the time of flight. I will apply s is equal to ut plus half it square to find the time of flight. So what I will get, minus h is equal to minus of half into g into t square. So t will come out to be under root of 2h by g. This is the time of flight which I am getting when the particle goes from point A to point B. So this is root 2h by g. One more thing which I want to calculate. I want to calculate the velocity v of the particle. So velocity can be calculated like what? From A to B, I will apply v square is equal to u square plus 2as. Either I can apply this or I can directly apply v is equal to u plus at, because now I have calculated the time also. So v square is equal to, initial speed is 0, so 0 plus 2 into acceleration is how much? Acceleration is minus g into displacement will be how much? Displacement will be minus h. So v square is equal to 2gh. So v will be equals to under root of 2gh. But because the velocity is in the downward direction, I have to take a negative sign. So it will be minus of root 2gh. Magnitude wise it will be root 2gh, but because I have to take a negative sign, that is why it will be minus of under root of 2gh. So I hope these particular concepts are getting clear to you. These cases can be applied. Now in this motion under gravity, a lot of questions can be asked. The basic feel or the basic concept will remain this only, that you have to apply kinematic equations to get to the final answer. I hope this particular point is clear to you. Now let's come to the next concept. Now let's come to the very important concept of graphs. So some basics of motion under gravity also I have given. Now let's discuss about graphs. Graphs in kinematic equation or graphs in motion in a straight line can be of displacement time graph. In displacement time graph, if information is asked, then always remember that the slope of or the area under the displacement time graph. See, two things are important. One is slope of a graph and one is area under the graph. Area under the graph means integration, slope of the graph means differentiation. You already know this. So if I talk about displacement time graph, the slope will give me instantaneous velocity. Instantaneous velocity. When I talk about velocity time graph, when I talk about VT graph or velocity time graph, in that case, two knowledge I can get. The slope will give me acceleration, basically instantaneous acceleration, and area under the graph. Area will give me displacement, because displacement is nothing but integration v dt from 0 to t. So area under the graph will give me displacement and slope of the graph will give me instantaneous acceleration. In the case of displacement time graph, the slope will give me instantaneous velocity, because we know that it is equal to dx by dt and we know that acceleration is equal to dv by dt. So slope will give me basically the velocity for displacement time graph, and for vt graph, slope will give me acceleration and area under the graph will be giving me displacement. One more thing, if I want to calculate see, this is displacement time graph, this is velocity time graph. Now I will calculate acceleration time graph. So I'm just giving you some basic information about all the graphs, what is important in calculating those graphs. So acceleration time graph mein kya hoga? The area under the AT graph, please understand, area under AT graph will give me what? Area under AT graph will give me integration a dt from 0 to t, and that will be nothing but change in velocity v final minus v initial. Always remember, area under the AT graph will give me a important information, that is change in velocity delta v, that is v final minus v initial. One more graph is there. Let me go on to the next page. One more graph is there, that is Vx graph. Suppose if I want to draw Vx graph, then how will I calculate Vx graph? So we know that A is equal to what? V dv by dx. Yes or no? A is equal to V dv by dx. Now let us suppose I give you a graph of V versus x. Suppose if I say that V versus x graph is given, this is x naught and this is V naught. They will ask you find the acceleration from this graph. Find the acceleration of particle. Find the acceleration of particle. And they have given you this particular information. Vx graph they have given. From Vx graph you can calculate the slope of Vx graph. What will be the slope? Slope will be nothing but equal to what? dv by dx. Now I already know that dv by dx when I will calculate, slope is equal to dv by dx. dv by dx, when I will calculate, I will get it as minus of v naught divided by x naught. This will be the slope of the particle, minus v naught by x naught. And I want to calculate v as a function of x. So v as a function of x will be how much? If I write the straight line equation from here, what I will get? I will get minus of v naught by x naught multiplied by x plus v naught. This is v basically. So if I want to find the acceleration, what I will do? I will write minus v naught by x naught multiplied by x plus v naught. This is v multiplied by dv by dx, which will be minus of v naught by x naught. So when you will multiply this, what you will get? You will get v naught square divided by x naught square multiplied by x minus of v naught square divided by x naught. This will be the acceleration of the particle. This is how you can get information, a very important information regarding Vx graph. So I hope some basic of graph is also clear to you, that what information can be given by what. Achha, one thing please remember in graphs, that whenever you draw a displacement time graph, suppose you draw a displacement time graph like this. Like this you draw a displacement time graph, let us suppose, okay? And they are asking you find the value of instead of displacement time, let me take velocity time. Suppose they have given you a velocity time graph like this, and let us suppose this velocity is 10 meter per second and this velocity is minus 5 meter per second. And they will calculate the displacement. Suppose displacement they are asking. So I already know that the area under the VT graph will give me displacement. But always remember, whenever, suppose this area is A1 and this area is, magnitude of this area is A2 and this is A3. Always remember, when you calculate the displacement, you have to take the area with sign. If it is a negative area, you have to take negative. If it is a positive area, you have to take positive. So what will be the displacement? A1 minus A2 plus A3, where A1, A2, A3 are the magnitudes of the areas. So this is basically the concept of the displacement time graph, velocity time graph. I hope these graphs are also clear to you. So we have discussed kinematic equations, basics we have discussed some questions of calculus, we have discussed some graph questions, we have discussed some concepts of motion under gravity. And now let us come to the next concept, that is projectile motion. Let's come to the next logic, that is projectile motion. Projectile motion. When we discuss projectile motion, so projectile motion will be what? Basically, projectile motion is the 2D motion. It is motion in a plane. It is a type of motion in a plane. Understood? It is a type of motion in a plane. Always remember, whenever any motion is happening in a plane, in a XY plane or YZ plane, then it will be basically a projectile motion, or it can be circular also, but here we are discussing a special type of motion in a plane, that is projectile motion. Now how to calculate all the things regarding projectile motion? Here what will happen is, let us suppose I have thrown a particle with initial velocity u, and let us suppose the angle with which I have thrown the particle is theta. So it will do a parabolic path, and that parabolic path, whatever it will do, I will prove that it will be a parabola. I have to calculate few things. What you must remember: first is I want to calculate the maximum height covered by the particle. Second is I want to calculate the horizontal range which the particle covers. Range means the maximum horizontal distance that the particle can cover in the horizontal direction. I want to calculate the time of flight, and I want to know the equation of trajectory. So all the things I am explaining, please understand carefully. Whenever you will do projectile motion questions, always break your velocity into two parts, horizontal and vertical. So u vector can be written as what? If you break it in horizontal and vertical, you will get u cos theta I cap plus u sin theta j cap. U cos theta I cap plus u sin theta j cap. What will be the acceleration of the particle? Obviously the acceleration is only acting in the downward direction. So the acceleration of the particle will be minus of g j cap. So initial velocity is given to you, acceleration is given to you, acceleration of the particle will be minus g j cap. Now I want to calculate all the things. So first thing which I want to know is the maximum height. See, I will again apply kinematic equations only. Please understand one thing. In projectile motion, there is no acceleration in the horizontal direction. Because there is no acceleration in the horizontal direction, the horizontal component of the velocity will never change. So the horizontal component, which is ux, which is basically u cos theta, that will always remain constant. That will not change because there is no acceleration in the horizontal direction. No acceleration in the horizontal direction. It will always remain same. But the vertical direction, if you see, in the vertical direction, the velocity is u sine theta. So in the vertical direction, it will just behave like a normal 1D motion under gravity. It will go up, the particle will go up, it will decrease its speed, then again it will come back to the same point. So vertically it is like this, that it is happening like motion under gravity, which we discussed, and horizontal motion is a uniform motion happening with constant velocity. So what will be the maximum height which is reached? The maximum height which is reached is basically u square sine square theta divided by 2g, or I can also write it as uy square divided by 2g. This is the maximum height which can be reached by the particle, that is uy square divided by 2g. I want to calculate the time of flight. So time of flight will be what? Time of flight will be 2uy by g. Time of flight will be 2uy by g. Maximum height will be uy square by 2g. I remember generally all these formulas in terms of vertical component of the velocity, because they are exactly similar like motion under gravity formula. So height is equal to uy square by 2g. Time of flight is equal to 2uy by g. Next, they will ask you range. So range will be what? Range, I already told you the formula, that range is basically the horizontal distance covered by the particle in projectile motion. So range will be equals to how much? It will be u square sine, see, I am not deriving the results right now because time is limited. So derivation I am not doing, just briefly I am covering the concept so that you can get a whole revision and then you can practice some questions. So u square sine 2 theta divided by g, u square sine 2 theta divided by g, or you can also write it as horizontal speed ux multiplied by time of flight. You can write both the things, it is one and the same thing. Acha, one more thing which you want to remember is that when will be the range maximum? So range will be maximum, please understand, range will be maximum when sine 2 theta is maximum, and sine 2 theta is equal to 1. If sine 2 theta is equal to 1, I can write 2 theta is equal to 90 degree, and in that case theta will be equals to how much? Theta will be equals to 45 degree. So always remember, if somebody will ask you that what is basically the maximum range, what is the angle at which I should throw the projectile so that it covers the maximum range, then that particular angle is how much? 45 degree. And what will be the maximum range? The maximum range will be equals to u square divided by g, because in that case sine 2 theta will be equals to 1. Achha, one more important point which you must know in this particular case, that if we throw projectile with angle theta and 90 minus theta, but with same speed, what do you mean by this? That means the velocity is same, u is same, but in one case I have thrown the particle at an angle theta with the horizontal, and in the second case I have thrown the particle at an angle 90 minus theta with the horizontal. In both these cases, always remember the range will come out to be same. R1 will always be equal to R2. Okay, I hope these points are clear to you. So we have calculated range also, we have done height also, we have done time of flight also. One more thing which can be asked in this particular case is the equation of trajectory of the projectile. So suppose if I throw the projectile at a velocity u at an angle theta, then this will be the path covered by the projectile. So what will be the equation of trajectory? Two equations you have to remember. The equation of trajectory can be written in two formats. What are the two formats? The first format is y is equal to, what is the x and y? Suppose at t equals to 0 you have thrown the particle, and let us suppose at any time x comma y, or the particle is at x comma y. This is at t is equal to t. So the particle has traveled here distance x, and here it has traveled how much? Y. So what will be the value of y? Y will be equals to x tan theta minus gx square divided by 2u square cos square theta. Y is equal to x tan theta minus gx square divided by 2u square cos square theta. This is one format of equation of trajectory which you must know. Here always remember, this will represent a downward parabola. It will represent a downward parabola. downward parabola. Why downward parabola? Because if you see here, this is quadratic equation, and for quadratic equation, basically there is a parabolic graph. Why it is downward? Because x square coefficient is negative. So this is basically the equation of trajectory of the particle. There is one more equation of trajectory which is basically manipulated from this format only. That also you must remember, y is equal to x tan theta. In the bracket you can write 1 minus x divided by r. So this is basically the equation of trajectory. Both the formats are very important. This also is important and this also is important. You must remember these formulae. You must remember these results for solving some good questions of projectile. So these are also clear to us. Now in this case, please understand one more thing. Till now, whatever case I discussed the case in which I was throwing the particle at angle theta from the ground. This particular projectile was ground to ground projectile. But now if I can do like this also. I can do a horizontal projectile also. Suppose if I throw a particle from a height h, from a tower at a height h, and let us suppose I have thrown it with a horizontal speed u. So here also it will do a projectile motion also. This will be the type of projectile motion which it will do. The acceleration is still acting in the downward direction. All the related formula will remain same. But the only thing which you have to remember is that here the horizontal speed will be u and I am throwing it at a height h. So कैसे calculate करना है? First we will calculate the time of flight. The time of flight comes out to be exactly equal to root 2h by g. I want to know the range also. I want to know how much range is covered. So range will be equals to what? Range will be given by the horizontal speed u multiplied by the time, that is under root of 2h by g. Now if you see properly, at this point you will get a velocity also. Here you will get a velocity. You will get two components of that. One will be Vx and one will be Vy. So what will be the Vx component? I already told you in horizontal there is no acceleration. So the horizontal components will remain same. So Vx will be equals to u, and in the vertical direction Vy will be equals to what? Minus of under root of 2gh. So if you want, you can calculate all these things by using the kinematic equations. You will get the answer. So V vector can be written as what? V vector can be written as u I cap minus of under root of 2gh j cap. They can also ask you the magnitude of this velocity. That will be under root of u square plus 2gh. So this will be the case in which I have thrown the particle from the tower at a height h with a horizontal velocity u. This is called as a horizontal projectile. This format is basically called as a horizontal projectile. Horizontal projectile. There are other formats also of this. The other formats are what? You can either throw the particle with a velocity u at an angle theta from a tower, or you can throw the particle like this, that from a tower you are throwing a particle with a velocity u at an angle theta. So here also it will cover like this, and here also it will cover like this. All these motions can be solved by resolving the vectors into horizontal and vertical, and by basically doing what? By basically using the kinematic equations wherever required. I hope these points are clear to you. So projectile motion concepts now you can solve, and I think the questions are not very difficult. You can easily solve the questions by the basics which I have already told you. Now after projectile motion, let me come to the next concept, that is relative motion. So let me discuss relative motion also. Relative motion. What is the meaning of relative motion? See, till now whatever concepts we covered motion under gravity, we covered projectile motion, we covered the concepts of acceleration, straight line concepts. In all these cases, the particle was moving with what? The particle was moving in a straight line. Yes. Because the particle was moving in a straight line, so there was and only one particle was moving. There was no two particles which are moving. So there was no concept of relative motion. But now what is happening is that let us suppose two particles are moving. Either they can move in a straight line, both are moving in one straight line, or they can move in any other direction also. So in that particular case, we want to know what is the motion of one particle with respect to any other particle. That means if I sit on one particle and if I analyze the other particle, what will be the velocity, or what will be the acceleration, or what will be the displacement of one particle with respect to another particle. So this motion is basically called as relative motion. So what will be the formula which will be applied here? Let me discuss. First formula will be displacement of A with respect to B will be displacement of A minus displacement of B. If you differentiate this term, you will get velocity. So velocity of A with respect to B will be equals to what? Velocity of A minus velocity of B. If you differentiate this further, what you will get? Acceleration of A with respect to B, that will be equals to acceleration of A minus acceleration of B. So basically, these are the only formulas which you require for solving the relative motion concepts. Now please understand one thing. Whenever you will apply relative motion concepts, then always remember that the distance between any 2 points and the time between any event will never depend on reference frame. Always remember that the distance between 2 points and the time of an event will never depend on the reference frame. So you can solve these two quantities in any frame of reference. You can sit on A and then you can solve. You can sit on B and then you can solve. The time interval will come out to be same and the distance between 2 points will also come out to be same. Let me write this point. This is a very important point. The distance between 2 points, and the time of an event do not depend on reference frame. Okay, this is a very important point. Rest all the other quantities will depend on reference frame. Like if I ask you that the displacement of the particle, will it depend on reference frame? Yes. Acceleration also will depend. Velocity also will depend. Everything will depend. But these two things will not depend on reference frame. Achha, one more point which you have to remember. Whenever you will apply this particular formula, displacement of A minus displacement of B, acceleration, velocity. Whenever you will apply this formula, always remember that these accelerations and velocities, these should be in the same frame of reference. To apply relative motion formula, to apply relative motion formula, acceleration, velocities and acceleration should be from same frame of reference. These two things should be remembered by you so that you can solve the problems. Now let me discuss some basic problems of relative motion so that you understand what is the concept. So one problem is riverboat problems. Very important. A lot of times the question also is asked. Riverboat problems. What do you mean by riverboat problems or riverman problems, whatever it is? The formula which will be used will be this. Velocity of boat with respect to river will be given by velocity of boat minus velocity of river. Please remember, velocity of boat with respect to river can also be written as velocity in still water. This can also be written as the velocity of engine or engine speed of the boat. Velocity of boat with respect to river can also be written as the velocity along which man wants to swim or man tries to swim. The velocity along which man tries to swim. Always remember, man in whichever direction boat or man is trying to row or trying to swim, it will not actually go there because the river velocity will actually take it somewhere else. But these are the terms or these are the terminologies which are used in the questions. If they will give you what is the velocity in still water, indirectly they are asking you to calculate the velocity of boat with respect to river. Okay? So these terms you should know. Now how to calculate these things? Achha, VB is what? Let me write VB also. VB is basically the velocity of boat with respect to ground. Always remember, this is the velocity of boat with respect to ground. And river velocity is what? River velocity you already know. It is the velocity of river with respect to ground. Okay? Now how to calculate this? Let me give you a logic. Suppose this is the river, this is the width of the river W, and let us suppose the particle or the boatman wants to row in this direction. This is VBR. And from this vertical it is making an angle theta. And the river is flowing in the horizontal direction like this. River velocity is in this direction, VR. So they will ask you to calculate the time to cross the river. They will ask you to calculate the drift. All these things they will ask. So how to calculate? Again, we will resolve it in two directions. What we will get? In one case we will get here VBR cos theta. VBR cos theta, and here we will get VBR sin theta, and here it is VR. I am assuming VR is more than VBR sin theta. So there will be VR minus VBR sin theta. VR minus VBR sin theta. So basically this will be the value of the velocity of boat, and finally it will reach somewhere here. The horizontal drift is basically this distance. That means from the initial position on the opposite bank, how much it got drifted in the right direction, that is called as drift of the particle. I want to calculate this also, and the width of the particle is given to me. Now please understand one thing. To calculate the time to cross the river, what I am going to do is, time to cross the river, I am calculating the vertical direction. So time will be distance upon speed in the vertical direction. Distance in the vertical, it has to cover W, and the speed of the particle with which it is coming will be VBR cos theta. This will be basically the time to cross the river. Acha, one more thing, if I want to minimize this time, for T minimum, can I say, see, W and VBR is not changing. For T minimum, cos theta should be maximum. Cos theta should be equal to 1. That means theta should be equal to what? Theta should be equal to 0 degree. Theta is equal to 0 degree. That means if I want to row in the minimum time possible, then the minimum time will be given by W by VBR. And for the minimum time possible, my angle of rowing should be 0 degree. That means if the particle or if boat or if man wants to cross the river in the minimum possible time, then he has to row the boat in this direction perpendicular to the river flow. That means VBR should be in the perpendicular direction. And in that case, the minimum time which I will get will be VBR, W by VBR. Achha, I want to calculate drift also. So drift will be what? Drift will be equals to what? Not in minimum time case. I am generally calculating drift. So drift will be what? Horizontal speed multiplied by time. Horizontal speed is VR minus VBR sin theta multiplied by time. Time will be how much? Time will be basically D divided by or W divided by VBR cos theta. So this is how you can calculate the drift also. In this case, one more case arrives. What case? The case is shortest path. Shortest path means the drift should be equal to 0. That means I want to actually go from this point A to this point B. There should be no drift. So the velocity of boat, actual velocity of boat, which is the velocity of boat with respect to ground, that should be in this direction. Now how this particular case will happen? See here. What I will do is, suppose the boatman tries to row his boat in this direction. This angle is theta and this is VR. So I already told you that please resolve it in two directions. So this will be VBR cos theta and this will be what? VBR sin theta. Now the resultant of all these three vectors should be equal to VB. But I am saying that if you want to cross the particle or if you want to cross the river in the shortest path possible, then the drift should be equal to 0. So what I am trying to say is that your velocity should be in the vertical direction. That means these horizontal components should cancel out each other. So that means for shortest path, VR should be equal to VBR sin theta, and in this case, sin theta will be equals to VR divided by VBR. VR divided by VBR. That means if you want to cross the river by the shortest path possible, then what you have to do is you have to basically row at an angle of sin theta is equal to VR divided by VBR with the vertical. But always remember, only valid when VR is basically lesser than VBR. It is only valid when VR is lesser than VBR. If the value of VR is lesser than VBR, then only you can apply. If VR becomes more than VBR, then drift will not be equal to 0. See, in this case, drift is equal to 0. In this case, drift is equal to 0 because you are exactly reaching at the opposite point. But in this case, if VR greater than VBR, drift will not be equal to 0. But for minimum drift, always remember, for minimum drift, the value of sine theta will be reverse, will be equals to VBR divided by VR. Always remember this thing. Okay? So this will be VBR divided by VR. So I hope this particular concept is clear to you, and this was the most important application of relative motion in 2 dimension. Okay? So basically this is basically the relative motion. Now let me discuss one more concept, and that concept is the Rainman problems. Okay? So riverboat, always remember, riverboat, 2 important concepts are there. The first concept is what? The first concept is that you have to cross the river in the minimum possible time. So for minimum possible time, what you have to do? You have to row, VBR should be perpendicular, theta should be equal to 0 degree, and you will not reach directly, you will be having some drift, but it will be minimum time. For shortest possible path, if VR is lesser than VBR, drift will be 0, and in that case, you can directly go to the opposite point. But if VR is greater than VBR, then drift will not be equal to 0, then you have to have some drift, but it should be minimum. So for minimum drift, you can apply this formula, sin theta is equal to VBR divided by VR. Now, let me take one more case, that is Rainman problems. This also comes sometimes. Rainman problems. So in Rainman problems, what happens? See, very simple. Again, velocity of rain with respect to man will be equals to velocity of rain minus velocity of man. And where will the man hold his umbrella so that he can be saved from the rain? In whatever direction man is seeing the rain. That means in whatever direction rain is appearing to come with respect to the man, opposite to that direction, the man should hold his umbrella. So always remember, man should hold his umbrella. Man should hold his umbrella opposite to the direction of velocity of rain with respect to man. In whatever direction man is perceiving the rain to be coming, the actual velocity of the rain is not important. Suppose the man is running and man is seeing that the rain is coming to me at an angle, then man has to hold his umbrella opposite to the direction of velocity of rain with respect to man to save itself. So opposite to the direction of VRM, the man should hold his umbrella. So in all these questions of Rainman problems, VRM direction is required. How to calculate the VRM direction? It is very simple. Let me take one case. Suppose the man is moving in this direction, and let us suppose the rain is coming in the downward direction. Obviously the rain will come vertically downwards. Let us suppose this is the actual velocity of the rain, this is the actual velocity of man. I want to calculate velocity of rain with respect to man. That will be velocity of rain minus velocity of man. So to add these or subtract these two vectors, I can directly do it, VR vector plus minus of VM vector. So कैसे करेंगे? VR vector is already downward. Minus VM vector you will do, so minus VM vector will be coming here. The resultant of these two will actually give me what? VRM. And I told you that opposite to the direction, you have to hold the umbrella so that you can get saved from the rain. So what will be the angle? This angle will be asked that at what angle from the vertical you have to tilt so that you can get saved from the rain. So tan theta will be equals to what? Magnitude wise it will be equals to perpendicular, that is VM, divided by base will be VR. So tan theta is equal to VM by VR. You can directly calculate and you can get saved from the rain. So I hope this particular concept is clear to you. So these were the basic concepts which are required for basically clearing the motion in a straight line and motion in a plane topic. Circular motion is also there in motion in a plane, but that will be discussed in a separate chapter. We will discuss it with Newton's laws of motion. I hope this particular concept is clear to you. Every concept has been discussed. Now please start doing the questions based on these concepts, and very important concepts have been discussed. You will be able to do the questions based on these logics. So we'll meet in the next video. In the next video, I'll be teaching you units and measurements and laws of motion. Okay? So thank you very much, and all the best for your RE-NEET exam. I hope that these concepts will be helpful to you. Thank you, beta.